Okay. Yeah, hope everyone enjoyed their snacks. Um, Hi everyone, I'm Sachin from the ZKP2P team. Today I'm going to talk about TLS proxy. Uh, Chris gave a talk on TLS Notary, which is like um, this like one project that has been in the works for like 10 years now, and it's like a very complicated protocol to achieve authenticity of a TLS data. But like the thing that I'm going to present basically achieves the same goal, but using like a different method, like a much cheaper method and much, I guess, slightly less secure, but way more performant compared to TLS Notary. Also, if you did not understand most of what Chris spoke, it's fine. Like, it took me a year to understand TLS Notary. I've been trying to understand it from last year onwards, and I still do not completely grasp it. So yeah, it's pretty complex. Yeah, feel free to interrupt me if you have any questions in the middle of the slides. Yeah, Chris already went over this, but like TLS has this verifiability problem where, let's say, if you want to share the response that you return from that you got from the server to some other verifier, you cannot convince them about the authenticity of the response because like the keys that are held by you are also like the keys that are held by the server are also held by you. So you can essentially like forge any response from the server and send that to the verifier. And there's no way for the verifier to tell whether the response is actually coming from the server. Yeah, and one way to solve this is like you do MPC TLS, where you do an MPC between the prover and the notary, and they basically like split the key, as Chris explained, like between the prover and the notary, so that the prover can no longer forge responses. And then you get authentication as well as you get privacy in selective disclosure. But another much cheaper way to achieve authentication is to basically insert the proxy in between the server and the prover. So instead of doing MPC, you just have the proxy sit in between the connection, and whenever prover sends a message to the server, like that is routed via the proxy. So the proxy is able to see all the encrypted request that is sent to the server, as well as encrypted response that is coming back from the server. And at least like the proxy knows that I have seen this encrypted request and encrypted response, which is coming from twitter.com or google.com, but they do not know like what does this like encrypted data contains. So one way to, I guess, convince them of the value of the data, like my username is 0xSachinK on Twitter, like you just reveal your private keys, like your session keys that I discussed here. You just reveal these session keys to the proxy, and then they can take the encrypted request or response that they saw earlier, take the keys, decrypt the value, and be like, yes, whoever this guy is 0xSachinK on Twitter. But then one issue with that is like you do not get privacy, right? Like if I'm sending the whole key to the proxy is able to decrypt everything. So let's say if I am trying to fetch, let's say if the server is a bank, the proxy is if the server is a bank, and if I reveal the keys to the proxy, then the proxy will be able to see my address, the amount that I have in my bank, all my transactions, so the entire TLS response. So how do we prevent that? ZK, like we just instead of sending the keys to the proxy, you just prove that you have a key whose encryption is the stuff that the proxy is holding. Formally, like it's like basically like I know a secret key SK and a public plain text request whose AES GCM encryption is the C request, and this C request is already held by the proxy. Also, this is like request sub because you do not, let's say if I am just trying to prove my username on Twitter or my bank account balance for a bank, I do not need to prove the encryption of the entire response. Like I just need to prove that one particular block that contained the value that I'm looking for. And since AES is like a block-based cipher, you can just prove like specific 16 bytes each time. So you just need to prove those specific blocks and convince the proxy that you have a key and you have a plain text for which the proxy already holds the ciphertext, and then you send that proof to the proxy verifies the proof, and then you can basically like get an attestation from the proxy that they notarize the fact that this guy is 0x Sachin on Twitter, or this guy has X amount of balance in his bank. One optimization for TLS 1.3 is like, instead of generating like a ZK for so TLS 1.2 we need to generate both for a ZK for request as well as a response. For TLS 1.3 it has like key updates. So essentially, like when you're talking to the server, you can say that while you're still in the request phase, you can update the key. So we can use that to basically like encrypt parts of the request that are public, and I do not care about the proxy knowing it, using one key, and then the encrypt parts of the request that I that I want to be kept private using another key, and then I just reveal the keys to the proxy. So at least for the request part, I do not need to generate a ZK proof. For response, I will always have to generate a ZK proof. Generally, like the key that I want to hide is the key that was used to generate the cookies, because if I reveal the cookies to the server, then to the proxy, then the proxy can take the cookie and then re-hit the server and get all my data from the server. Okay, yeah. Any questions? No questions? Cool. So what is the difference between TLS proxy, which is, we call this method TLS proxy, and TLS notary? There are certain pros and cons. That it is like much faster and reliable today. We have like at ZKB2P we have used both ZK email and TLS notary in production, and that's why both of the teams briefly mentioned us. But like TLS notary like suffers with a reliability problem today, because like you're doing a bunch of complex MPC stuff and it has like a lot of bandwidth overhead, and there's a very high chance that the MPC might like before you are able to complete the MPC, the TLS connection just drops off, so you're not able to complete the whole process. They are working on it, trying to optimize it. Hopefully they ship V8 before DevCon, which should be way more performant. But at least right now it's not like that usable in production. Another, I guess, so TLS proxy right now, it will be much faster and reliable today. I'll give a demo at the end. Also, like unlimited response size. In TLS notary, like when you get a response from the server, you have to do the MPC on the entire response, whereas in TLS proxy you can generate ZK on just parts of the response. So like you're not constrained by the response size. So if you are proving this very small parts of the response, you're much better to go with TLS proxy rather than TLS notary. Cons, like it is like less secure. So because we are having a proxy, so we have this proxy instead of MPC. This means that like anyone can insert themselves in between the proxy and the server. So the prover can insert themselves here, which means instead of the server returning the bank balance, the prover itself will return the bank balance. So the prover can say, my bank balance is $1 billion, and there's no way for the proxy to tell whether the response is actually coming from the server, because this is TCP, not TLS. So at least this connection is TCP. So that's right. Also, no censorship resistance. Like the proxy knows which server it is talking to, whereas in the case of the notary, like the notary doesn't know which server it is talking to. So you can generate proofs for, like the EF can run a notary, and you can generate proofs for any website. Finally, like I guess one important point to take away is like both the TLS notary and TLS proxies, you have to trust the notary, which I guess Chris alluded to as well. Yeah. I think one thing that we need to be like very clear about, like ZKTLS is very hyped these days, but I think one thing that we need to clear about is that ZKTLS is not a solution to the Oracle problem. Neither TLS notary nor TLS proxy nor other opacity or other protocols out there, none of them are a solution to the Oracle problem, because you are trusting the notary, right? Like at the end of the day, you are either trusting one notary running in a TE, or multiple notaries, but you have to trust the honest majority. But then you are trusting someone. Like it's not completely trustless, as trustless as Ethereum. So Also, if you want to bring public data, might as well just sign it rather than using zk-TLS. So if you're thinking of like use cases which involve public data, do not use zk-TLS. If it is private user data, then it is like a much better fit. Yeah. So that was all theory. Like, what are the tools that are available today to build something using this? There are a couple of tools available right now. Plus, we at zk-P2P are also building TLS proxy implementation funded by PSE. Like one, I guess, why are we building it? Given that there are already existing implementations out there. 3 reasons. One is better performance. So we will be using interactive zero knowledge proofs Quicksilver compared to like ZK Snarks, and those have like the biggest, I guess, advantage that we'll have is like the peak memory is just 65 MB, whereas compared to here it's 500 MB. So you can generate proofs on like Android devices or very cheap devices which are not an iPhone. Like iPhone has good amount of memory and has decent speed, but like you cannot generate ZK Snark proof on Android. So we will need an interactive zero knowledge proof. But like again, anything that is interactive comes with the bandwidth overhead, but turns out the bandwidth overhead is like very small for Quicksilver, which is like under an MB. Combine this plus this, it's under an MB, which is like a decent trade-off. This new tool that we're building will be compatible with TLS Notary. So like the API, the tools, like everything, like TLS and JS, hopefully their Explorer, everything will be compatible with our thing as well. And it will be open source and MIT licensed. We are still building it, so if you want to use it, like if you want to build something using zk-TLS today, you can use Reclaim, which use the ZK Snarks version. Also, this is like a QR code to the paper, which has the security proofs for the proxy implementation. Yeah, these are some like use cases that you can build today using zk-TLS on off-ramps, which like these are the three things that we have built. This is something that Zap Labs is building, plus as this as well. Like they are trying to build this, and this is something that we have built. Yeah, questions? Go ahead.
I had another question. For the proxy, this idea that came looking at your presentation, we could have multiple proxies, like
yeah, but
so like we could be like it's not going to be like a two party, but it can be like let's say 4 parties, like just put one proxy after the another.
Yeah, I've also thought of that as well. Like you can, what he's saying is like you can insert multiple proxies in between the proxy and the server, but it is still, you're still trusting just one proxy, because like for example, if let's say if there are 2 proxies here, whatever this proxy is saying it's coming from the server, this proxy has to trust the other proxy, right? So at the end of the day, this proxy can be fooled very easily. If this proxy is malicious, this proxy can fool this proxy, and then there's no way to tell whether who initiated this, or like it's like a something to think about, I guess. Like maybe try to formalize it a bit more, but I think that's like one biggest problem. Like how do you make sure that this proxy can be honest, even if this proxy, like in the sequence that
maybe with TE, like
I don't think TEs will help with that.
And another thing that came to mind is, since it's going to be integrated with the TLS Notary library, could have like a proxy plus notary, because the proxy can just be proven after the TLS session is finished. So you have one proxy there, you have the attestation of the notary, and then later on, after everything is finished, you also have an extra attestation from the proxy.
Although like I don't think that adds anything.
It becomes 3 party instead of 2 party. Like you would have.
Oh, I see. Like the proxy and the notary will be
yes,
two different parties.
Two separate entities, and that would increase the security consumption from having to trust just the notary to now you have someone extra.
I see. So you're saying like the notary will be here?
Yes.
Prove a notary, and then that will be forwarded by the proxy.
It doesn't change too much in the bandwidth aspect.
Yep.
And then once the notary part is finished, you can have an extra proof from them. And I think that's the beautiful thing of you guys implementing the TLS notary library, because then you can try to build a path that integrates both.
Yeah, I think that's a cool idea. I hadn't thought of that. Yeah, we can at least increase it to like 2 out of 2 assumption rather than 1 out of 1
That's
assumption.
huge, actually.
Yeah.
That's huge.
Nice. Any other questions? Go ahead.
I wanted to ask about the benchmarks for, it said like 50 milliseconds to prove one AES block on an iPhone.
Yep.
So what kind of snark are you all using again?
So this is a, like ZK Snarks version is implemented by Reclaim. The proving system that they're using is NARC.
No.
And AES is like heavily, like you can use, like since it is like deterministic, you can use lookup tables. So they are using a bunch of lookup tables in NARC to get like this performance.
Okay.
I'll also very quickly show a demo. Hold on. So this is like the domains marketplace that we have. You can peer-to-peer trade domains here. We have a bunch of domains listed. I'll create a listing right now. Create listing. Hold on. So this is the extension that we have. Like Chris also showed their extension, but there's like their extension is open source. We have built our own extension for proving stuff. So what I'm going to do is like list a domain right now, a domain that I own on Namecheap. I'll prove ownership of the domain and list it on the marketplace. So, let's see. I think I've not listed this one, so so right now we are generating a ZK Snark proof. Okay, proof generated. I'll go back to the page and then register the domain on chain. And then list it for 0.18. Sorry. So this is the proof generation process, by the way. Like this is where I proved that I own the domain on Namecheap. I'll go back to the listings and like now like any one of you can bid on this domain. Hold on. Yeah, any one of you can bid on this domain and try to buy it from me. Cool. That's it. Thank you. Hold on.
Thank you. Next. Yep. Put the microphone in.
Just clips on.
Yeah, you need to.
Oh, okay.
Cool, that's good. Cool.
All right. So, what's up, everyone? I'm Lance. I'm working on a project called Saray. If you observe my necklace, it's actually a real symbol. It comes from the Akan word Insarewa, which is a Ghanaian word meaning prosperity and happiness. So, the story of how the project got started was I started nomading in Nigeria, and I really couldn't pay for anything. At least fairly. So I met someone who would exchange my crypto, but if you follow this conversation, you'll see that it was really hard for me to get a fair exchange rate. And actually this problem happens for lots of other people across the continent of Africa. So I traveled to Ghana, Tanzania, Kenya and experienced the same problems. High ATM fees, sketchy cash dealers, and overall not a straightforward way to off-ramp my crypto, for example, USDC or ETH, into a local fiat currency. That was until I experienced this program called Bangma in Kenya, where I was able to meet a lot of the builders building other projects in the space. But one thing that I had realized was that despite so many projects being built, everyone was using USDC or USDT, some type of US-backed currency or stablecoin for on and off ramping. So one of the things that I got from this recent stablecoin summit at Edge City was that with on-chain forex, swapping foreign exchange could be lowered. The cost could be lowered as much as 80%. And then also on and off ramping overall, even for small transactions, can cost up to around 6%. So we want to de-shitify this. This is a shitty process. Excuse my language. And there are other projects that are doing local stablecoins, such as Mento with Celo, Wi-Fi, and Haraka. But all of them essentially create synthetic stablecoins, local stablecoins, from other assets. So overall, it's actually inflationary. So this needs to be fixed. This is the volume of stablecoin, and it's essentially all USD. I'm actually American. I'm not like anti-USD. It's just that I think that this works. If we're building a global system, it should actually represent the globe, right? Ramping should not be a foreign exchange transaction. So we need liquid local bonds to actually be used for the governments to actually issue or at least indirectly issue these stable coins. And then also trustless on and off ramping. So that's what we're building with Saray, is simply local bond-backed stable coins along with a secure way to on and off ramp. So just a quick diagram of how we're building it. Right now we're using TLS Notary for off-ramping specifically, and then some proxy TLS for on-ramping, probably Reclaim, hopefully we use ZK P2P. And then also we're using some collateralized debt positions to actually mint the stable coins from the bond tokens, because a lot of these bonds are more risky, so you want to have more liquidity in exchange for less stable coins. So we have a quick demo here just for the off-ramp TLS Notary experience. So let's say you're in Ghana and you want to pay somebody just 50 cities, right? Which is around $5, I think. And you just put in their phone number. A little bit of context here is that in most African countries, people pay each other through their phone number. Right? So the telecommunications providers actually have payment rails embedded into their networks. So what you can do is integrate with the telecom service provider and then just pay. So right now, I don't know if you saw that, but it was in ETH exchange rate. So in the first version of our project, we just use ETH to local currency, and then we use USD to local currency. But right now, we don't have like a local stable coin to actually make a cheap off ramp. So right now we're just doing straight ETH to Ghana US or Ghana CD. So we hit confirm, and as you can see, so I'm gonna just bring up these logs here. So these are the logs on our server, and as you can see right now, we're establishing a connection with a notary client. For this test.saray.xyz, we're just using the PSE notary servers, but in our production application, we actually use our own notary server. What we want to do is actually run it in a TEE or maybe make like an eigenlayer notary system. But yeah, so as this is generating, typically takes around like 60 seconds. I wanted to go into just a little bit of the story, like our development story. So at first we actually wanted to use ZK email, but what we had found is that a lot of the bank transfers that are done, for example, in Ghana and Nigeria, they aren't signed with DKIM signatures. So ZK email was kind of off the option list. And then also we wanted to integrate Nigerian payment service providers with TLS Notary, but unfortunately, companies like Paystack and Flutterwave, it takes a lot to actually use those services. For example, you need to have a certain level of liquidity, and as a bootstrap company, we were thinking, what is the easiest way to do this? So it was why Ghana was a much easier choice for us. And then as you'll see later in the presentation, we've actually settled on Botswana because it's kind of like a golden country. It has AA rating bonds, and then also it has really friendly crypto regulation. So as you can see, the payout is completed. You paid out 50 Ghana cedis to this recipient using your Ether. And then if we look in the logs, we should be able to see a complete notarization. Yeah, so these are the transaction details on chain. So that means we got paid for facilitating this off-ramp. And then, yeah, so here you can see that the notarization was complete. So we essentially want to use this MPC TLS for off-ramping and then ZK TLS for on-ramping. So back to the presentation, what you'll notice is that this actually isn't a P2P service. We're just a server who's using TLS Notary to verify that we're acting correctly. So we think that this is actually advantageous approach because of regulators. They want to know who is actually moving the funds around. And if they can have one singular party to say, hey, are you all, KYCing properly? Are you all following regulation? We can be the ones to be responsible for that. And then also one thing that we've been thinking about is ERC 3643, where it's essentially a special type of ERC20 token for regulated assets. So you're able to freeze accounts, you're able to force transfer, which kind of goes against Web3 like morals, which we're not going to do it at first, only if we absolutely have to. And then another thing that we wanted to explore was a project, it is SXG verification on chain. So the central bank, or a lot of central banks, they post their foreign exchange feeds, at least Ethiopia, I believe. They post their foreign exchange rates online for anyone to see. So what we're thinking of is rather than fetching prices from something like a custom oracle, which could cost a lot, and then also would require multiple participants, we can just use a verifiable web scraper made with like SP1 or RIS0, scrape the Bank of Ethiopia's website, and then host that with an SXG server, and then verify those signatures on chain so that you can get these prices for the stable coins without even having to set up oracles, completely free. So like I said earlier, we're targeting Botswana. They have a really strong bond. It's low probability of default. And then they also have a relatively stable currency. And then their total government debt is around 3 billion in the total addressable market. So why stablecoins? It's a lot of reasons, but over the past few months, of course, with conversations with Joseph as well, it's been an obvious demand where it's not necessarily being built. And for us doing on and off ramping, it just makes sense for us to have this so that you can on ramp with just 1% and then do your foreign exchange from there. Right, so I think from this list, my favorite is the on-chain foreign exchange. There's this paper by Uniswap that was released that just kind of gave perspective on what it would look like if most foreign exchange activity happened on-chain. You get instant settlement, you get much cheaper rates, and then you also just have a lot more security. Of course, the benefits of DeFi versus TradFi. So there's also this paper that we were reading, just called The Hierarchy of Money, which we're Kakai and I, which is my co-founder, you'll see him in a few slides. We've been thinking about what is the best way to design a stablecoin that is backed by local bonds. And there's this paper that detailed like what is the hierarchy of a stablecoin, where, for example, in DAI's case, it depends on other stablecoins tied to the same value, like USDC. So, for for example, there are curve pools with DAI to USDC, and then also the DAI peg stability module depends on the stability of USDC, right? What happens if DAI didn't necessarily directly depend on USDC? It depended on, maybe traditional finance or maybe even the Federal Reserve T-bills themselves. So this is what we're studying, is if you had a stablecoin, how do you tie it to the root of the issuer as closely as possible so that it can gain legitimacy? And why do you need legitimacy? Is because these governments are already thinking about central bank digital currencies, right? So the Bank International System of Settlements has already been experimenting with central bank digital currency experiments, where I believe they had one in Hong Kong, where you're able to digitize your fiat and send it across via blockchain. And then also there are companies like Hedera that are already working with entities like the Nairobi Securities Exchange to tokenize their stocks and facilitate exchange on a blockchain. And then also Nigeria and Ghana have already experimented with central bank digital currencies. So this is just something that we see it coming. It's just a matter of proper execution and making sure that everyone's values are aligned. So this was a tweet that my co-founder released yesterday. Unfortunately, this bill that they have been fighting for a long time, I think before it was much higher, but they issued a 3% digital assets tax on all crypto transactions in Kenya. So even if you're sending funds to a smart contract, you get taxed. So it's something where if we're going to do these central bank digital currencies, let's make sure that everyone's values are aligned here and that we're making fair solutions, which is also something that I've been talking to people around Chiang Mai. Here is it's coming to a point where these two realities are I don't want to say clashing, but coming together in a way that it would be very nice. Oops. Okay, I'm low on time. So last slide. This is just the quest to bring programmable cryptography to regulators. Imagine if regulators were able to have the guarantees that they want while maintaining the privacy and the sovereignty principles of blockchain. Being able to actually accept a zero knowledge proof as legal attestation. I think that's a green field that we all can go toward. So with that, it's three of us co-founders, and we're building. This is a website. It just has basic information right now. But if you want to go to the website that I had done this demo on, it's just test.surrey.xyz. And if you have Sepolia ETH, you can use it for fun. But right now, this is illegal, so we can't take it live just yet. And thank you very much.
You mentioned you're using TLS notary for off-ramping and proxy flow for on-ramping.
Yeah.
Why is that the case?
That's a great question. So for off-ramping, we're actually the ones who are facilitating the payment. So we have a Rust server that's running. We might run it on some GPUs just to make the process faster. But for on-ramping, you're typically working with people who are using mobile money on a mobile device. So they're typically going to be doing something like generating a proof from their Safari browser or their Chrome browser on mobile. What we wanted to do was actually work with MPC TLS Notary for the WASM bindings on mobile, but it only works for Microsoft Edge on Android, at least the browser extension. So it was something where, at least in the meantime, rather than waiting for the MPC computation to finish before you on-ramp, you just use the ZK TLS option to go much faster.
So you mentioned 2 points. One is you want them to be able to use on their phones, and then second, you do not have the voice on my times, right?
Yeah. We do have the WASM bindings. It just takes too long, and it's only available on select browsers.
No, but you can just run the WASM. You can compile it to WASM and then run it on an app.
Yeah. on a mobile app. Yeah, but the time. Yeah, it's a bottleneck.
So you guys are the liquidity provider for on-ramp, off-ramp, right?
No, not yet.
Okay.
So what we're working with now, we're just showing the proof of concept, and ideally we want to work with like a specific blockchain to give us a grant, and then we actually experiment with the.
So in the demo, am I paying someone?
No, it's complete. Like you put in any number that you want. It's just testnet,
What is
like
it
playground.
supposed to show me? Like, is it
The off ramp, right? So you are in Ghana. You want to pay someone Ghana cedis. So you put in the amount of Ghana cedis. You put in their phone number, literally, and then you can pay them with your ETH. It's not live though. It's just a Polia ETH.
But the payment will go from your bank account to this guy's bank account. So you will pay on their
It will go from my crypto wallet to his bank account, or not necessarily his bank account, more his mobile money account.
So it will go from your crypto wallet to Survey's crypto wallet, and from Survey's bank account to this guy's bank account.
Not our, so our smart contract, right? So you send your crypto to the smart contract.
Survey's
Yep. And then we send the fiat
to this guy.
to this guy, and then we do the MPC TLS proof.
Is that legal?
Is it legal? No, definitely not. That that's why it's not live.
Would it be legal even in, like, I think like the fundamental problem that these regulators have is like you need to be able to track the source of funds, and if you
Yeah.
are paying on someone else's behalf, then it's like it's very difficult.
Yeah,
You have to convince them about it.
that was one of the reasons why we're thinking about the 3643 tokens.
Why not give the money to the user itself? So he sends you crypto, you send him, you do a peer, like as in peer to merchant exchange.
Okay.
And he can pay to the taxi driver or the market.
So it's more so a on and off ramp directly. Okay, so the situation is that if you are just a general crypto user, you don't have a Ghanaian SIM card, you're not able to do that. If you were to go to Ghana right now, you're not able to receive Momo or mobile money because you don't have a Ghanaian SIM card, and you need to stay there for a year to get a permanent residency, and then you can get a SIM card. But it's more so just to open up the financial infrastructure, right? So even without a SIM card, you can use this and then pay straight from your crypto wallet. That does make sense though. Yes.
For the still on project, like, what is the biggest challenge you guys are facing right now, and like, what would be a key priority for the next 36 months?
Yeah, for sure. It's for us, it's about who is going to be that bridge of trust between the blockchain and like our actual custody bonds, right? So what we're thinking about is hitting up a law firm, DLA Piper. They have bases in Botswana, Kenya, I mean all over the world. And what we were thinking is actually using the bond or purchasing the bonds and then using them as a trustee. But then you still have just a legal agreement binding them to custody the bonds while we have them on chain. So are they going to make them permanent like the blockchain will? Who knows? You know, so it would be nice to have something like an API that you can access to DLA Piper's, maybe their storage or like whatever their trustee services are, to actually, you know, maybe make another MPC TLS proof saying, hey, I can verify that this law firm in this country is custodying this amount of bonds. Right now, Circle just uses Deloitte audits, but they're monthly, and we think we can do better. Yeah.
How are other like companies that are tokenizing U.S. bonds and treasuries approaching it?
Yeah, so it's just open audits, mostly. I know Circle does open audits, USDT, they're doing open audits. I mean, baseline, I think it is relatively safe. We're just thinking about the continuous nature of crypto, and how, for example, if you're doing the Silicon Valley Bank crash, it was more so like speculative on, okay, I know Circle has holdings in Silicon Valley Bank, so I know that they may be insolvent. But what if you could get that feed live and say, hey, Circle, can you prove that you have assets in Silicon Valley Bank? Or are we going through a bank run? You know, so I think that'll be a next level of locally backed stablecoins, is if you can somehow bring these technologies to the incumbents and then come up with some type of like on-chain verifiability of whatever's backing these stablecoins.
Do you know countries that are already doing that?
Yeah, so there's this project in Argentina called Numan. Oh, wait, are you familiar? Yeah. So they're a really dope project issuing stablecoin. I'm not sure if they're doing on and off ramping, but they're issuing stablecoins and then also like a yield bearing token for the Argentinian peso, right?
Not only Argentinian, but the other coins of Latam.
Oh, Brazil, right? The real.
Like in Colombia,
Uh-huh.
several countries.
Yeah, absolutely. Yeah, I was gonna go to the Crecimiento Day, see if I can meet somebody, but do you know them?
Yeah.
Word. Okay, so then we'll connect. Awesome.
Like, I mean, this is so necessary and this solves so many problems for us.
Mm.
So these are the solutions that we need the most. So congratulations.
I appreciate that. I appreciate that. Yeah, it's just about making it cheap. Like you onboard to your local currency, and then from there you just have fun with DeFi. Mm. Yeah.